Hello, this video is a follow-up on my previous space colonization video. Now, I wish I was talking about outer space colonization. I am not. I'm talking about an algorithm called space colonization, which is outlined in this PDF paper here that you can find a link to in this video's description. And it is possible with this algorithm to generate trees like this. So last week, time doesn't matter here, but in my previous video, I made a version of this algorithm. I actually did it in JavaScript using a JavaScript library called P5.js, but I have this same code running now in processing. And I switched over to processing because the point of this video is to extend this algorithm into 3D. So I want to take, and let me run it here for you. I want to take this idea, which is using this branching algorithm. Come on and run, please, code. Using this branching algorithm to take this from a 2D world to 3D. So let's talk about how this has to happen. So first, what's the basic idea for this? What's the basic idea behind this algorithm? So the idea of this algorithm is that you have a canvas, and you fill this canvas with points. And these points are known as leaves. So maybe you fill this canvas with a bunch of points, and then maybe you start at the bottom. And you create a branch segment, and you keep growing branch segments all the way up until you get close enough to some of these leaves. Then what the algorithm does is it says, okay, any leaf that's close to this particular branch segment, pull a force, have it become an attraction force. So maybe this one and this one are close, so a new segment is made. And then this one and this one and this one are close to this one, so a new segment is made here. But this one is also close to this one, so another new segment is made. So all of these leaf points become these points of attraction that start just pulling out these branches. And you can see that happen. I'm going to come back to the code, and I'm going to change here. I'm going to in setup. I'm going to say frame rate. I'm going to just say 5, so 5 frames per second, and we can watch this happen a bit more closely. So you can see here these branches are getting pulled and pulled towards all of these points. And as they get pulled towards these points, those leaves disappear. Now, there's a couple things I want to mention about this. I'm kind of recapping my previous video, but I think it's worth it before we move to 3D to make sure we understand all the pieces here. So number one, I just want to kind of recap. This particular program has a set of objects. It has a leaf object. That are these seed points here. It has a branch object. The branch object being these particular segments, all of these segments. And then it also has a tree object. And the tree object keeps track of an array of branch objects and an array of leaf objects. So the algorithm goes something like, for every leaf, see what branches are within a minimum and maximum distance, and add a force to those branches, and then have all those branches grow a new branch off of them with the direction of that force. So the tree itself is iterating through all the leaves, then applying forces to all the branches, then making new branch segments. And as leaves are close enough to a given branch, they get deleted. So this leads me to an issue, though, that I feel like is worth resolving in this example before we move on. Look at this. There are some leaves that just won't go away. They're there. They're stuck there. I can find another one. Over here is another one. The reason why it's stuck there is that they're magically somehow exactly equidistant from a particular branch segment. So the force can never go towards one to get a little bit closer and then be removed from the system. So I don't know, I'm looking at you, internet, watching this video to come up with solutions for this problem. I had a wonderful solution suggested by Oliver in the chat recently, which is just to give each branch a little bit of extra random force to it, so that every once in a while as it's going there, it'll randomly turn. And in that case, it'll eventually find these branches, these leaves, and get removed. So let's add that here. And I'm going to go to the part of the algorithm where we add those particular forces. And actually, what I want to do, I'm going to do that in a different place than I did it before I was practicing this. So this is where those new branches get added. And this is where the branch's direction gets averaged based on how many forces were applied to it. So what I want to do right here, I'm just going to try making another random vector. And I'm going to say, I'm going to add that. So right before the vector is about to be, right before the new branch is about to be born, I'm just going to give it a little bit of random motion to it to see if it can, like, when it's getting stuck, if it can skew towards one of those leaves. So let's run this again. Oh, and I have the frame rate at 5, so let me cancel that out. Let's run this again. Come on, I don't know why my Command R isn't working. Oh, I'm in debug mode, no wonder. So, oh, that's way too much. Look at that. That kind of ruined it. It did something, but it's kind of like crazy now. So I probably shouldn't have added it here. Okay, so let me go back here. Let's try to make that not so strong. Let's make it really, really weak. So I'm going to set its magnitude to something much, much weaker. And you can see maybe that wasn't strong enough. So it's still like I've got these equidistant spots there. So let's make it 0.1. That seemed to do the trick. There's a couple spots that are still stuck there. Let's try 0.5. It's a little less kind of like curvy and fractally, but it did work. So I'm going to just like try 0.3. That looks pretty good. So I think I settled on 0.3 as kind of my number that I want to do. So you can see I at least have now resolved that problem. The reason why I wanted to resolve that problem is I'm going to add something. I don't want to be adding branches infinitely. And the other thing I want to do quickly to this before I move into 3D is show you, let's do something that's changed the thickness of these branches. So every branch right now has a stroke weight of 1. But what if branches that are made earlier at the center are thicker than ones that are at the edge? So a way that I can do that is right here. This is where I'm actually drawing a line for every single branch. So every single branch here is just a line between the branch's position and its parent's position, connecting the one that's connected to it to itself. So one thing I'm going to do here is just change this loop to a regular loop using index I to branches.size. The reason why I want to do that is what I want to do now is I want to say each branch is going to have a stroke weight. So for example, if I say stroke weight 10, you can see all the branches are really thick. They have a thickness now of 10 pixels. But what if I were to create a variable and map its index? So the older branches are added at the beginning of the array. So its index goes between 0 and branches.size. And have that go, so the earlier ones have a thickness of 10, and the later ones at the end have a thickness of 1. And what if that is its branch thickness? You can now see we've got something here where the earlier they are at the beginning, the thicker they are, the more at the outside, the less thick they are. And I could like mess around with this mapping. I could just start with 5 or 6, and I could actually go down to 0 to get them like much skinnier even at the end, which is kind of nice. So I think this looks kind of nice, and you can imagine how this might have, what kind of effect this might have depending on how you're seeding the points and where you're starting the root of the tree. Okay, so I somehow said this was a video all about 3D, and I probably spent 10 minutes here just getting ready for that. But we've recapped the algorithm, and we've also made it a little bit better by adding thickness here and solved a particular problem. And now we can actually do something that I believe will be quite simple in turning this into 3D. So let's think about this. So this is what's happening in a two-dimensional plane. I created in the canvas, I just created random leaf points anywhere. So what I want to do instead in 3D is I want to think of the canvas not as a flat plane, but as a sphere. So I'm going to create random points all inside a sphere, and then I'm going to have my first branch, the root of the tree, in the center of the sphere. Again, if you really want to create a tree, what you might do is create some kind of like ellipsoid in 3D, seed all the points, start the root at the bottom. But I'm just going to do something simple just to get this algorithm working, and then it's up to you to be creative to try to create a different set of seed points with a different starting branch. Okay, so let's come back over here and see if we can do this. Okay, so the first thing I need to do if I'm going to move into 3D is just add P3D. Oh, I'm not here. Is just add in size P3D. So what did I just do? I just added P3D. So I want to. So now it's rendering in 3D. I can actually just run this and see like, hey, same thing, but it's actually in 3D. Now, just so we can like get a sense of the camera a little bit better, I'm going to add a library called PeasyCam. So I've already installed this library. If you haven't installed this library, go to Add Library under Sketch Import Library. But I've already installed PeasyCam, so I'm just going to click Import. And all I need is this import statement at the top. Then I need to create a PeasyCam object. I'm going to say cam equals new PeasyCam. And I have to say this. So PeasyCam is this library that just automatically like makes this mouse interactive camera so you can spin around and zoom in and out of your scene in a very default way. And what I need to do, so I need to say this, referring to this sketch is where I want this camera to take over. And then I also need to give it a Z value, like how far away do I want to be looking at it. So I'm just going to say 100 for right now. And then I'm going to run this and sort of see what happens. So I can't seem to find, like, oh, there it is. So I'm off. One of the things that PeasyCam does for you is it makes 0, 0 the center of the window as opposed to the top left. So here in my tree where I'm creating the leaves, I actually want to create them. I want to create, well, first of all, I want to create the root at 0, 0. And then where I'm creating the leaves, I want to make the leaves not offset by the center of the window anymore. So let me just do that, and we should see now, there we go. Now, one thing is I'm kind of zoomed in, so I can zoom out and I can spin. But you can see now this is totally flat. This is kind of a nice effect just in and of itself. So I still have my two-dimensional space colonizer, but it's in 3D. And I want to look at it from further away. So let's make that 500. So you can see here. So this looks exactly like what we had before, but secretly, it's in 3D now. So this is actually, I believe, going to be incredibly simple. All I need to do is instead of making a two-dimensional plane of leaf points, right? I'm not actually, let's not call grow. So what do I have here? This system is just a whole lot of points in a two-dimensional plane. Why are they that? Because all I did was make random 2D vectors. So watch how simple this is going to be. Random 3D. I want to make, random 3D vectors, and I'm going to run it. And now you can see, whoa, okay, so what's going on? I made 3D vectors, but I only see two-dimensional points. Well, there's a bit of a problem here, which is that my points are ellipses. So what I want to draw, I need to draw those at their three-dimensional location. So I'm going to change this to translate pos.x, pos.y, pos.z. And now the ellipse can be at 0, 0. And I'm going to say push matrix, pop matrix to make each ellipse its own thing. So I'm going to run this now. Oops, let me zoom back out. And you can see now I have this, let me zoom back in. I have this 3D sphere of points. Now they're ellipses, so as I turn to the side, they're no longer facing forward, and I can make them spheres. You know, there's any number of things I could do. Let's just make them spheres for a second, just for fun. What's more fun than making them spheres? I'm just curious to see how slow this runs. Now notice, look how slow this runs. So I don't want to make them spheres because I don't even need to see them for this algorithm to happen. But spheres require a ton of rendering because each sphere has like a zillion polygons. And I could reduce the detail in the spheres, and there's all sorts of things I could do. But I'm just going to leave them as ellipses. So I'm going to run this again, and you can see here, now I have this. So now all I should be able, I should just be able to grow the tree. I mean, all the math is going to be the same whether it's 3D vectors or 2D vectors. So let's grow the tree again. I'm going to turn grow on. And we're going to run it. And let's see what happens. If something is working, I can see all those branches happening. It didn't fit. But look, it's still flat. It's so sad, it's still flat. So why is it flat? Well, am I drawing the branches in 3D? I probably have a line function that's just doing 2D. So let me go back to the tree, all the way at the bottom. This is where I'm drawing each branch as a line between the branch's position and its parent's position. So I just need to add the z-coordinate for this line. And I got to scroll all the way to the right here to get also b.parent.pos.z. So now I should have a three-dimensional line. And let's see what happens. It's growing, it seems to be getting everywhere. And now, look at this. There we go. Look at this crazy three-dimensional, wacky, strange shape that I have. And I can zoom on into it and look inside and scroll around. And we can see there's different thicknesses. It's thinner on the outside. Now, some leaves just didn't get reached. And it's hard for me to, I can't tell if I have this equi-distant problem anymore. I don't think so. I think some leaves are just kind of too far away. So, there's some ways around that. I could futz with this sort of minimum and maximum distance. Like, let me make the maximum distance 200. And I think that's going to help things. So that I think that's probably going to, you can see now I got to everything. So that just by increasing that maximum distance, leaves that are kind of too far away will get found. Now, here's the thing. There's a bunch of things that I've done here. Yeah, it doesn't look, someone in the chat writes, it doesn't look like a tree. It doesn't look at all like a tree. So maybe before I go, I'll make this look a little bit more like a tree. But here's really your job. So your job is to be a designer. Come over here, please. So what have I done? All that I have done is create sort of a default view of the algorithm working. So, and think about it in 2 dimensions. I made a sphere. I filled the sphere with points, and I started in the middle, and stuff is growing out. So really, I almost made this like veiny, blood vessel-y like system. So if you want to make a tree, you've got to be more thoughtful. So on the one hand, I made a suggestion of what if you kind of create, and actually something like this might work well. What if this is all your seed points look like this? And then you actually start the root from the bottom. So you need to come up, what's your and if you read the space colonization paper, it will give you suggestions. What's the volume where you create all of your seed points? And then where do you start the root? So that's, on the one hand, going to make it look more like a tree. The other thing you need to think about is just, I just use three-dimensional lines, which aren't really, there's not a lot to them. So you might think about, well, actually, what you want to put are cylinders for each branch segment. And maybe you want to texture those cylinders with some kind of like wood-looking texture. And then you want to add some lighting to the scene. And then maybe you actually want to put, at the points that are at the end, you want to actually put actual leaves on like various parts of the branch. So I think there's a lot of kind of visual dressing that you can add. So there's your seed points, how those seed points are organized. There's where you start the root. Those things will get you sort of closer to the tree, as well as your sort of visual dressing. What's your lighting? What's your texturing? How are you drawing the branches? Are you adding like leaves attached to the branches? That sort of thing. So I would like all of you to explore those types of things. Okay, yeah, the other people are saying it looks like connections in a brain or a plasma ball thingy. Those are all excellent points. So let me at least get you started to show you where you can make these kinds of changes. So I'm going to save this as Space Colonizer 3D. All of the code will be uploaded on GitHub with a link. And I also, let's just add a few more things to this before we go. So what I'm going to do is say, let me make the scene that we're looking at a bit taller. So I'm going to make it 900 by 600. We can see, sorry, I want to make it 600 by 900. So I want to make it kind of, oops, oh my goodness. I hit something by accident here. So you can see I just want to have my window be a little bit taller. And then what I want to do is have the leaves start, I want the leaves to just go out by like, still be a sphere, but I want to offset them. So I want to say y minus equal like height divided by 2. So that should offset everything up. Yeah, there we go. So, so this is what I wanted to do. But then I also want, so that's way too much. And then I also want the tree's root So in the tree object, the root gets a point. I want it to actually start at the bottom of the window, which is 0, comma height divided by 2. So I want to start the root at the bottom. So this is a bit more tree-like. So how successful this is, I'll let you be the judge of that. But you can see just by having kind of a tree at the just by having like a sphere of points up top and the root of and starting the root at the bottom, you get this kind of stalk root-like thing, and then it starts to branch out at the top. But again, maybe there's a uniform distribution of random points now, all in that sphere. Maybe there should be even more along the top and less on the bottom, or some type of like cone shape. I encourage you to experiment with it. But this, I think, will get you a little bit further into seeing it's kind of tree-like. And I'm addicted to spinning around this. Okay, so I think this concludes this video. I'm just gonna, some people in the chat are asking like, what did I do to change? So let me just mention again, since I did that kind of quickly. In the leaf object, this beginning function right here, this is where the initial leaf positions are set. Every position is a random 3D vector scaled according to the width of the window, which is about 300 pixels. And then I'm offsetting it by height divided by 4. So moving all the y positions up. That's where all the leaves are set. Now, where does the tree begin growing? The tree begins growing in the tree object, and the variable is this root branch. So the root branch, incidentally, has 2 arguments. The root branch gets where it's positioned, so 0, height divided by 2, so down at the bottom. And also that vector is the direction where it starts growing. So incidentally, if I were to change this to this, we'd have a problem because nothing would happen. The tree is growing off to the right to infinity. So it needs to grow up, so to speak. There we go. Okay, so look, the process of it growing is really quite lovely and nice. And it'd also be interesting, like, all those branches are objects. What if you start moving the points after the fact, add some physics to it, have it blow in the wind? So many possibilities. Okay, so this was much longer than I had intended, but this is hopefully a nice follow-up to the previous space colonization in 2D video, and what I did here was fix a few things about it, add thickness, move it into 3D. I hope that you make something with this and that you share it with me. In particular, add your own kind of visual design spin to it, and I look forward to seeing what you make. Thanks for watching.